These 10 jaw-dropping truths about Africa ripping itself apart reveal how a drying climate could be turbocharging a brand new ocean. This is the story of an ocean being born in slow motion, and in some places not so slow. Where maps show a smooth continent, the ground is quietly unzipping, the air is getting drier, and the deep earth is pushing up like a silent engine. Watch closely and you can see tomorrow's coastline sketching itself across today's savanna. 10. The continent is literally tearing open. The ground in East Africa is cracking like a zipper, and it is happening faster than anyone expected. Stand in the Afar depression of Ethiopia and you can feel it. Salt flats shimmer below sea level, black lava oozes from fresh fissures, and the crust sounds brittle underfoot. Salt flats shimmer below sea level, black lava oozes from fresh fissures, and the crust sounds brittle underfoot. Here is the plot twist. The sky might be part of the trigger. We usually say plates move first and climate follows. Here the climate might be giving the plates extra pull. When water vanishes from big lakes, it removes weight, eases pressure, and lets faults slip. This matters because it means what happens above ground can accelerate what happens deep below. The seam of a future ocean is sensitive to rain gauges and heat waves, not just to magma miles down. 9. The Red Sea and the Gulf of Aden are proof this has happened before. Earth's crust is not one shell. It is a mosaic of giant plates that grind, collide, slide, or pull apart. About 30 million years ago, the Arabian Plate started moving away from Africa. Seawater rushed into the gap and gave us the Red Sea and the Gulf of Aden. Along their floors, long ridges of volcanic rock mark where new seafloor is built, and magnetic stripes frozen in the crust record the pace of that spread like tree rings. That history lesson is the blueprint for what is coming next in East Africa. The ocean has invaded once, and it can invade again. Think of the Red Sea as a baby ocean that grew up. East Africa is the delivery room for the next one. 8. East Africa sits on a three-way stretch zone. Scientists call it a triple junction, and the bullseye is the Afar triangle. The Arabian Plate is moving away. The Somali Plate is peeling from the Nubian Plate. All three are diverging. Picture fabric pulled from three corners. It thins, weakens, and then snaps. From space, the shape is a giant Y, one arm up the Red Sea, one along the Gulf of Aden, and one diving south into Africa's heart. That triple tug makes the crust easier to rip. This matters because three-way divergence concentrates stress and focuses where the next big cracks will open. It's the difference between a slow tear and a sudden rip, the kind that slices through rock layers like pages in a book. 7. The ground is moving inches per year and building new crust. The Arabian Plate is sliding away from Africa at about an inch per year. The Somali and Nubian plates separate more slowly, from about half an inch up to 2 inches per year. That is hair growth speed to us, continent cracking speed to Earth. Where they pull apart, hot material rises from deep inside Earth, cools, and becomes brand new seafloor. In places, molten rock injects sideways as blade-like dikes that can be miles long and only a few feet thick, geologic crowbars prying the crust open. GPS stations bolted to bedrock and satellites that watch tiny surface shifts confirm the motion day by day. Scale that motion across geologic time and you get entire coastlines, new currents, and a different world map. 6. We are watching this in real time. In the Ethiopian desert, a massive rift opened in 2005, an event called the Dabahu Dike Intrusion, and in places the crack yawns about 20 feet wide. From space, satellites show valleys and rifts slowly widening year after year. INSAR images, radar snapshots that can detect ground motion of less than an inch, paint the rift like a living heartbeat. On the ground, people record deep fractures slicing through roads, houses, and even schools. Pastoralists detour their camels around fresh scarps. And the volcanoes are restless. Erta Ale's lava lake bubbles like a cauldron, and cones flare to life with little warning. This is not a distant textbook concept. It is visible, measurable, and it is unstoppable. That immediacy is why this story demands attention now, and why the people who live along the rift are already adapting to a future that geologists can see coming. 5. A new ocean is on the way. As the rift widens, waters from the Indian Ocean are expected to surge inland and fill the valley, tugging the land apart even more. At first, it may arrive as narrow seaways and salty lagoons, breeding grounds for coral and mangroves where there is now dust and thorn scrub. Over millions of years, Eastern Africa could split away. Parts of Somalia, Kenya, Tanzania, Mozambique, and a big chunk of Ethiopia could drift from the continent. Countries like Zambia and Uganda could one day have coastlines. The timeline is 5 to 10 million years. That is forever to us, but it is record speed to Earth. A sixth ocean taking shape, carving out future shipping lanes and reshaping weather patterns along a brand new marine frontier. 4. Africa's climate flipped from wet to dry. During the African humid period, the Sahara was green and water was everywhere. Hippos and crocodiles cruised across what is now desert. Ancient rock art shows swimmers. Lake Turkana in Kenya sat hundreds of feet higher than today. The shift to a much drier phase dropped lake levels across the region. Monsoons retreated, dust storms rose, and rivers withered. Heavy lakes act like thumbs on a scale. When those thumbs lift, the crust flexes and faults loosen. That shift sets the stage for faster tectonic action, linking changes in the sky to cracks in the ground. 3. Lakes double as tectonic scars. Researchers pulled sediment cores from Lake Turkana to reconstruct water levels and sediment flow. Inside those layers, they found tiny faults and signatures of ancient earthquakes, little offsets, sudden influxes of shattered grains, and ash layers that date the jolts. That means the lake itself is likely a giant crack that filled with water. The same may be true for other deep, narrow lakes like Lake Malawi and Lake Tanganyika along the rift's western branch, world-class trenches where the continent is unzipping. These lakes are not just basins, they are windows into active rifting, with steep underwater cliffs, submarine landslides, and quake scars etched in mud. Reading them tells us where the crust is failing and how fast it is changing. While the living world, Cichlids in Malawi, gas-charged depths in Kivu, adapts to the shifting stage above. 2. Drought can make the ground slip faster. When lake levels fall, there is less water weight pressing down on the crust. Think of loosening a vise. Faults can slide more easily. At Turkana, the data show fault motion speeding up by about a few thousandths of an inch per year after the wet period ended. Over thousands of years, that is a big push. The effect is twofold. Faults unclamp and fluids move. There is also volcano pressure to consider. A volcano on the south side of Lake Turkana sits above a pocket of molten rock. When lake levels drop, pressure above eases, more rock can melt, and that extra melt swells the magma chamber like a balloon. That added pressure can jolt nearby faults and trigger more movement. The result is more quakes and more slip in a landscape already under tension. It is the same principle that wakes up some volcanoes when ice sheets melt, remove weight, and the deep earth responds. 1. A superplume is the deep engine. The ultimate driver is a colossal upwelling of hot rock rising from deep within Earth. It pushes on the crust from below, weakens it over time, and opens the rift. This African superplume has been lifting plateaus from Ethiopia to Kenya, feeding chains of volcanoes and heating the base of the plate so it peels more easily. It is a collaboration across scales, from clouds to crust to core. Here is the big takeaway. The sky and the solid Earth are not separate stories. Put the pieces together, a triple junction pulling in 3 directions, inches per year that add up to an ocean, real-time cracks we can see from space, a climate shift that lifts weight off faults and pumps magma into volcanoes, and a superplume that keeps the furnace roaring. That is why this breakup is moving at what feels like record speed. It is a collaboration across scales, from clouds to crust to core. Here is the big takeaway. The sky and the solid Earth are not separate stories. Droughts and lake levels can tip the balance on faults primed by deep mantle heat. Human history already bears the fingerprints of this dance. Our ancestors walked the Rift Valley, guided by lakes that appeared and vanished with the rains. We may never swim in that future ocean, but we are alive at a rare moment when a continent is splitting and we can actually watch it on satellite screens, on cracked highways, on the shores of shrinking lakes. Stay curious, because the next time you see a headline about cracks in Africa, you will know the forces writing that story, from the whisper of dry winds to the slow thunder of rock rising from the deep. Subscribe for more unbelievable facts.